problem I want to do here is if I've got a trammel, which is the picture here is a trammel of Archimedes, it draws a curve, which is in fact an ellipse. What I'd like to do is find where I could put the foci of a string, pinned down string construction of ellipse. So what kind of length of string would I use, and where would I put the foci? So let me model that in the trammel in geometry expression. So here I can model it quite straightforwardly with a line for the trammel's arm, and I'll put a point for the slider. The axes are going to be the slots that the sliders operate in. You can specify the length of the trammel's arm to be A and the distance between these two sliders to be B. This thing's now going to behave like a trammel. We're going to specify the location of C on the x-axis, make that parametric location T, and that means we can define a locus of B as T varies. Looks like that. We can change the limits on T to get more of the curve. So okay, here's half of my curve. What I'd like to do is create a curve using a piece of string. Here's how I'm going to model that. I'm going to put the two foci distance f from the y-axis. That's what is distance f. I'm going to specify the length of this line to be s, and the length of this line to be L minus S. And so the sum of the two lengths is going to be capital L. That's the length of the piece of string. And now I can ask for the locus of this point as S varies. Again, we can change the parameters of S, the limits on S to make that cover more of the curve. So now I can see I've got another curve, but it's not the same. Now, the first thing I'd like to do is, well, what length of L could I use? If I vary L, I can see I can get the thing to be longer. Let's just change A here. That's the length of my trammel. Let's make that 5 for the moment. So I've got a smaller trammel. Now I can tweak L until the ends line up. And I can look with A equals 5, approximately 10 is a good length for the string. If I move A to be 5.5, then I can look for an L which is going to work, and that's about right, and that's close to 11. I could make a conjecture that it's actually L is twice A if we look at and we can look at the string model to convince ourselves that in fact that makes a lot of sense, that the distance from the center to the edge of the curve is in fact A, the length of the trammel arm, and that the when it's out at the edge, the string traverses twice the length. So that little bit of geometric reasoning can convince us that instead of L in here, we should have 2A. And so now I see if I vary A, that both curves vary appropriately. Now they're not the same curve. We need to work out where F should be, and that's what I'm going to do next. Let me just see what happened there. So what we're going to do next is find the equation of these curves. So the equation of the trammel generated curve look like that, and the equation of the string generated curve is going to look like this. So if we look at those equations, they've got y squared is times a squared. We've got some sort of constant here, but the coefficient of x squared, here we see it, and one curve is a squared minus f squared. Let's grab that. And the other one is this expression. Let's grab the inside of it. So we would like this thing to, we'd like to know what f should be. We can pull a squared over there. And there we have it. If we can get rid of the minus sign, which I believe we can this way. Right. So f is the square root of that, and we can go back into our model. And we can see then if we change a and b, we get both ellipses to work together.